Tutorial sheet 1, question 2. In this video I'm just going to look at the first two parts of this question. So we're given this signal x of t, which is equal to 3u of t minus u of t minus 2. And we're asked, first of all, to plot x of t as a function of time. Well, it says sketch and label. So what we need to do is, first of all, we need to know what both of these individual functions look like, so we can split it into two parts. So first of all, we'll just look at the first part of that, 3u of t. So we're going to look at 3u of t. Well, very simply, the unit step function, we know that that is 0 before time is 0. So we have a value of nothing. And then we have an amplitude of 3. And that will go on to time infinity. If we look at the second part of that function, this is going to be minus u t minus 2. Well, first of all, we know we've got a minus, so we're going to be looking at negative amplitude. And then how do we cope with this t minus 2? Well, we know that u of t changes from 0 to 1 at time t equals 0. So what we need to work out is at what time does this argument t minus 2 equal 0? So in other words, t minus 2 is equal to 0, or t is equal to 2. So at time 2, that's where this one becomes minus 1, because we have this minus function in. So if we were to plot that entire graph of x of t, we know we have an amplitude of 3 until time 2, and then we have to subtract 1 off, and it goes on to infinity after that. So that's how you work out part 1. Part 2 asks us to work out the derivative, dx by dt. So we can write that as the derivative of dx by dt is equal to the derivative of 3u of t minus u of t minus 2. Now, this is a linear operation, so we can split these two operations up and have two differentials. And hopefully at this point we'll recall from question 1 on the tutorial sheet that if we differentiate a unit step function, we get an impulse function. And 3 is just a constant, so we can bring that constant out, 3 delta t. Again, let's not forget the minus. We get an impulse function, but it's a time shifted impulse function, t minus 2. So if we want to know what that looks like versus time, well, at time 0 we're going to get a delta function at 3, and we actually need to go down to minus 1. We draw that. So at time 2 we get another impulse at negative 1. So we've just got two impulse functions.